Okay, good morning, friends. Today, in this chapter, we will discuss the charging infrastructure and the various applications of EV. What is the voltage required for all the three segments, like two wheeler, three wheeler, and the four wheelers? So, let me start my session with the sales of EV, the statistic report received from EV Reporter. At the month of September 2025, the sales of various segments like two wheeler, three wheelers, e-auto rickshaws, battery electric vehicles, hybrid electric vehicles, PHEV, apart from various categorization and various architectures of EV, the sales of two-wheeler segment is too high when compared to other segments. This is also one of the proof which I shown here. So day by day, the sales of EV is increasing gradually with a linear characteristic. When talking about the a battery pack, so formerly now it is on lithium ion battery we are using in all the segments. Now we are categorizing the same battery into low voltage battery and the high voltage battery. Low voltage battery is nothing but can be able to charge under level 1 and level 2 charger. Whereas high voltage battery has been deployed in electric buses which only able to charge using only charging stations. So from this slide, you can refer the third column. See the typical voltage range required for the battery. For a two-wheeler and a three-wheeler, from 48 to 96 voltage is required. So I can able to step down the voltage by using a DC to DC converter, which can be able to charge or which able to charge my vehicle which comes under the level 2 charger. Level 1, level 2 charger. Whereas in case of high voltage battery, even low voltage battery and high voltage battery is fully made up of with a lithium ion. The charging voltage required for the battery pack is 400 to 800 voltages. We are getting from the grid, either it's a single phase or three phase, will be getting a 230 voltages. So we are getting a 230 voltage AC as a single phase supply for my home. It is very difficult to provide a voltage to charge your battery from 300 voltage to 400, like hatchback cars, sedans, and the higher end cars, or electric buses, or high trucks, heavy trucks. When the battery pack is too high, that is the level of capacity, not the volume of the battery or not the size of the battery. So based upon the energy capacity of the battery, whereas in high voltage battery, you can say that 30 to 80 kilowatt hour battery is required, which can be able to charge under level 3 charger. So as per my ultimate target, the extended range vehicle, the long range of vehicle can be achieved when I'm using a level 3 charger. That is when the battery pack comes under high voltage battery. Only that high voltage battery I can able to charge less than a minute. Now, under the research, now currently it's not available. Maybe in future, definitely will take as much as possible, lesser minute to charge in order to achieve a long range of vehicle. A single time, a 100% SOC will be giving the overwhelming responses in an EV, patching beyond a 350 kilometers. So shown here, currently I am using a 15 to 30 kilowatt hour a battery pack for the four-wheeler segments. For example, if we're going to have a Tiago car, right? Probably a 24 kilowatt hour battery is required. Whereas in MG Comet, a 17.3 kilowatt hour battery is required. So for this 24 kilowatt hour energy capacity battery can able to drive the vehicle, the maximum target to drive the vehicle is 250 kilometers. But the 250 kilometers depends upon the driving pattern also. Simply by deploying a 15 to 30 kilowatt battery in my vehicle, even though the driving pattern is not in a proper way, it's not depends upon the terrain also. Simply placing a 30 kilowatt hour battery, I cannot expect a 250 kilometer with a single charging. So all the efficiency of the entire vehicles depends upon the who is going to drive the vehicle, the maintenance of the vehicle, the driving pattern of the vehicle, then the terrain of the vehicle. Here, the only one question is, what is the need of charging infrastructure? Why not for all the vehicles could be charged in domestic homes? The requirement of the charging profile, it means a voltage. The requirement of the voltage, requirement of the current to charge the battery pack to bring SOC 100%. What is the time limit required? It's fully determined by the BMS. BMS is nothing but a battery management systems. This BMS should protect your battery and also should protect your vehicles, and also it should be properly communication to be done between the charger and the battery pack. If it fails, if you're going to have a continuous charging without the knowledge of BMS, think about the SOH of the battery. Definitely going to affect the health of the battery. We have to concentrate more on the battery pack because, for example, I can say that if you're going to buy an 1 lakh rupees of an EV, maybe two-wheeler or three-wheeler, that is the 60% of the cost is went only for the battery pack. So I need to put more concentration on my battery pack, how to charge, when to charge, what is the charging rule when I'm driving, that is during a starting and the stopping conditions. My charger should support the specification of the charging port provided in the vehicle. Where each and every company has a unique charging port design. So I cannot able to charge my vehicle at wherever and whenever fast drainage in the battery pack. That vehicle should reach the lower the charging profile, that is lowest SOH near to the charging station. I'll be very happy. But I cannot expect my vehicle whenever it going to drain the battery, the nearest place should be an where a charging station is provided. Instead of that, what modification can be done in the existing charging technology in my vehicle with the safety measures? How the communication from the battery and the charger can be done either through a CAN bus, that is CAN L or CAN H. You have to think about that. So there are 4 charging methods are there. Number 1, a conductive charging. Number 2, contactless charging method. Number 3, a dynamic contactless charging. Number 4th is a battery swapping technology. It is one of the point we need to think, or we need to bring the consideration. Only the battery swapping will be plays a vital role, or can be play a superior role when all the battery pack design for all over the company if it is same. The battery swapping will be very easy with a unique charging port also. So I no need to able to wait for more than 6 hours or 7 hours to charge my vehicle. If Tesla, for example, Tata and Mahindra all together brings the common charging port with a constant charge specifications. If all the 3 companies, I'm saying this for example, these 3 companies I'm considering, if you want to have a 48 volt 16H, either Tesla or Tata or Mahindra, all 3 were using, then I can build my charging station with the same voltage specification with the current rating. Then I can able to swap the battery between this with common spec. But currently it is very difficult now because each and every company is having a unique designs with a unique specification also. Then when you're talking about the contactless charging, that is either the inductive charging or capacitive charging. Whether I'm going to charge my vehicle under static charging or dynamic charging. Whether I'm going to charge my vehicle under standstill conditions or under running conditions. If I'm going to charge the vehicle under dynamic charging methodology, then I no need to bother about the range anxiety. Because definitely there will be one vehicle either behind or adjacent to my vehicle is going to drive on the on road. Then I can able to charge my vehicle from there with the integration of AI. So that's a good communication can be made between 2 vehicles. Then I don't need to bother about the range extension. I can able to travel wherever I like if the charging of the vehicle is done by the dynamic charging method. Whereas the conductive charging, AC charger and DC charger depends upon the low voltage battery, either 48 or 72 voltage. That is AC charger and DC charger depends upon the whether going to onboard charger or off-board charger vehicles. So I need to think about that. Under these 4 charging methods, when I am going to charge my vehicle, whether by charging among these method will bring high efficient, can be able to reduce the emission of carbon. If I want to arise the question, then I can simply say that if I want to charge my vehicle under these modes, then I need to bring the charger or I need to bring my battery pack to the formerly a reliable power. Reliable power means reliable voltage, constant voltage. You know that I'm going to retrieve the constant voltage from the battery, but due to a driving pattern, the speed of the vehicle gets varies depends upon the terrain, load, and other performances and the other parameters. Then I need to charge my vehicle under different modes. So from this slide, it is clearly known that there are 6 types of charging methodologies there. Number 1, a CC is nothing but a constant a current move. When I'm going to charge the current with the constant value, then I need to clearly monitor the voltage of the battery because here I am supplying a constant high current to my battery pack to charge within a stipulated time. Then there is a possibility of overheating in the battery pack. Then it's going to affect the SOH. The SOH will be very weak if I'm going to charge my battery pack continuously in the constant current. If you're going to prefer a constant voltage, here also overheating is the major disadvantages. If I'm going to provide a initial high starting current to my battery pack to brings my voltage to be constant. So as a result, there is a possibility of high inrush current will flow from a charger to the battery pack, which will affect the performance of the battery. Then again, I need to bring my cells in the battery pack to be equal. Now to attain high efficiency, I need to implement a cell balancing methodology if you're going to use an CC mode or CB mode. There are two types of balancing method is there. Active balancing and the passive balancing. So it is very difficult in balancing the cells. That is the main function of the BMS is to monitor the voltage, current, and temperature by using a sensor. We need to think about that. I need an quick charging within the stipulated time with high efficiency with the range extension also. So better neither a constant voltage, neither a constant current. I'm going to prefer a CC, a CB voltage so that I can avoid the high inrush current. Once it reaches the maximum permissible SOC, for example, nowadays the BMS in all the devices up to 80% going to charge. Beyond the 80% won't charge. So for example, if we're going to fix the endpoint as 80% until starting from 0 to 80%, my charger will provide a constant current mode. Once it reaches the benchmark of 80%, then the mode switch over to a constant voltages. So performance of the battery pack will be maintained evenly with reduced temperature. If you're going to provide a constant power, because I said earlier, here the electronic converter is going to act as a interfacing devices between the charger, battery and the motor. So if we're going to provide a constant power, what will happen? The high current will flow until with the lowest SOC. Current goes down as charging progress. If it goes on increasing the SOC, the linearly the current will decrease. It is very difficult. The advanced technology pulse charging, variable current charging methodology is also there to charge your battery pack. But out of these 6 modes, the highly preferable mode is constant current, the constant voltage mode. In this slide, I'm going to represent these are all the building blocks of EV charge. Number 1, power conversion unit. Number 2, communication port. Number 3, electric vehicle supply equipments. Number 4, connector and cables. What is power conversion unit? This is nothing but a charger port. The communication port is nothing but PP. This is called a proximity pilots, control pilots in the level 1 charger or level 2 charger or CADMO charger. You'll be having apart from this power earth unit, the CAN H. H means high, CAN low, then PLC modems. Electric vehicle supply equipments. Either it is an onboard charger or off-board chargers. Finally, connectors and the cables, which comes under which standards. The standard is more important in building an EV because the charging plug inbuilt from the EVSE, whether the connector is inbuilt to your vehicle or like an off-board charger, the maintenance of standard is more important. So before getting to the charging infrastructure, we need to have an look what are the problems associated with it. I'll be very happy if my charging infrastructure, that is the range of battery pack, to be sophisticated. If you're going to charge with the public station with multiple integrated systems. Then optimization of a battery pack with the safety, with the downtime, that is lowest time, with lowest maintenance cost, which makes me to switch over a new transportation era from the conventional IC engines. So these are all the important to be kept in our mind. Because without the charging infrastructure, we could not be able to promote EV. Even though it is a zero emission vehicle, if we're going to have a fuel cell electric vehicle, in that if we're going to have a green hydrogen as the fuel cell, then will it be a zero emission vehicle. But without the charging station, where I'm going to charge my battery pack or my vehicle? Then second thought is the range anxiety. Because currently now charging station is somewhat far away from one place to another place. Between the among the two charging stations, there is a little bit distance is too. So users, whether they are reliable on the charging infrastructure or other methodology of charging their battery packs. Then third point is clean mobility. When you are switch over from conventional fossil fuel to EV, you are going to reduce the emission of greenhouse gases. Then integrations. The fourth valid point is integrations. So when I'm going to have an infrastructure with the other renewable energy sources, so I'm not going to rely on the fossil fuels. Fifth point is the commercial growth. When I'm migrating a new transportation era from conventional to new trends, then there is a biggest industry opportunities, the interactive, what the industry needs today through an conclave, through another conferences. We can able to identify what the industry needs today between the consumers and the business peoples. So indirectly they are associated with good career opportunities. The last, planning, doing and act, PDA Act. Definitely this EV will be the future ready transportation networks. So this slide represents how does the charging infrastructure impact EV. So charging infrastructure significantly affects how far the existing vehicle can travel before the requirement of the charger. Then the consumers should be knowingly where the charging station is placed with its number. Then charging station should be located between every 50 miles so that the range anxiety can be avoided. When I'm going to have a quick charging in my vehicle, then I can easy to plan a longer trips. Then consumer decision is more important. Now currently, the insufficient charging station is forcing the driver to shorten the trips. In future, definitely if we're going to have an n number of charging station within 10 kilometers, maybe the selection of EV will be more comparatively with today. So when compared to last year, this year the 5 lakhs EV has been sold with the totally of two-wheeler and three-wheeler and the four-wheeler segments. The linearly increase, the 200 times sales has been increased when compared to previous year. So the indirectly all the consumers, they are contributing and reducing the emission of carbon footprint towards their ecosystem of the environment. So when I'm going to deploy or I'm going to erect a charging stations, then I need to build the confidence among the consumers. The charging station should be visible. The more incentives are required for the charging station providers. Before that, the logistics adoption there, the EV should play a vital role. The advancement in the technology, right? The fast charging, V2G, G2V, smart grids, the integration of renewable energy, integration of AI will make us more feasible and flexible adoption of EV when compared to conventional IC engine. So in this slide, I can indirectly say that the sales of the EV, either battery electric vehicle or hybrid electric vehicle or plug-in hybrid electric vehicle, the marketing of EV and the sales of EV are gradually increases linearly, either front wheel drive or rear wheel drive or all wheel drive, right? Apart from these three, the BEV is plays a vital role. A pure battery electric vehicle is going to have a predominant a character in future, apart from hybrid electric vehicle. Due to an oil crisis is the next criteria. So without the oil crisis, as I said earlier, 2038 may be the zeroth day of the fossil fuel according to energy statistica. I don't know. Maybe EV engineers will find the different pathway for extracting the minerals from the earth, but not up to the expected level. The sustainability or development of the essential components without affecting the features, it should be there. Then we need to think about the cost savings. What about the cost of the vehicle? If there is a lack of fossil fuels, then definitely there will be an hike in the fuel price. These are all the parameters under consideration to think why not EV. So I am shown here that comparatively the EV is superior than the IC engines. So the time consumption for charging my four-wheeler segments starting 30 minutes to 8 hours. So it depends on the charger. Either I don't know whether it comes under the level 1 or level 2 or level 3 charger. I have shown here slow, fast 3, ultra fast. DC charger, AC charger and the DC to DC charger. But when it's refueling your petrol tank, it takes only 3 to 5 minutes. But the running cost of your vehicle is very low in EV charging stations compared to the IC engines. The convenience and smooth starting and stopping can be achieved only by the EV. I can able to charge my vehicle, which comes under the level 1, level 2. Even I can able to charge in my home as well as in my office. Whereas if I want to use an IC, then I need to go for the fuel stations. Even the integration of renewable energy makes us me to think, why not EV? Maintenance also very low. As I said earlier, 50,000 plus components are deployed in an IC engines. If you are having n number of components, then n number of maintenance will be there. If I'm having a less number of components, then obviously the maintenance cost will be very less in EV. So there are few challenges associated with the EV charging infrastructure as of now. The reliability, the offline charges can lead to revenue losses because, to be frank, for going to a charging station, if parking lots are not there, let me take an example. For each charging station, we will be having only 4 parking slots to charge my vehicle with a unique voltage and unique current rating. The consumers from the other end, whether you will meet the same requirements, there is a possibility of frustration of the consumers. So by integration of AI, with the communication can be done easily, whether there is lots available or there, what is the specifications available in the charging stations, whether the accessibility of the charging station are user friendly. So charging stations in high traffic areas, the poorly located charges, which makes discourage the investors. So the charging station should be user friendly. It should be applicable in all the either off peak during an on peak time. So fast charges are essential. Whereas here the fast charging means a DC to DC fast charging, which could be able to provide a 400 voltages. The energy capacity of the battery pack will be too high. So better we can prefer level 1 charger or level 2 charger. Can be feasible, user friendly. Home charging is very common. So we no need to go for charging stations. Only thing is we need to concentrate more on the EVSE, electric vehicle supply equipments. Because these components these are all the interfacing devices going to transfer energy from the battery pack to the motor for both onboard charger, offboard charger vehicles. So the type 2 connector J1772 charger. This is the schematic representation of the charging layout because I need to provide a safety message for the battery pack as well as for the vehicles. So let me clearly see in this slide. So it is an onboard charger, because I'm going to charge my vehicle directly from the grid system. So I can say that, take it as a best example for level 2 charger, because I'm going to charge my vehicle from the grid. So it is a general onboard charger structure layout. Here I need to introduce a safety interlocks between the rectifier and the grid voltage, because I'm going to tap the voltage from the transformer 2 kilowatts to 22 kilowatts. So I'm going to give without any safety measures to the rectifier. If there is a frequent voltage fluctuation happens, then there is an limitations in the switching rating also. There is a condition of introducing and safety measures between the grid voltage and the rectifiers. Actuators are introduced between the grid voltage and the rectifier. Figure rectifier is going to convert AC into DC. Then again, the fixed DC, in order to get a regulated DC output voltage, I'm going to prefer a DC to DC converter, maybe the Zeta converter or SEPI converter or flyback converter. Usually the flyback converter will be using as a AC to DC converter, where we are using a mobile charger to charge my mobile devices. So fixed DC to fixed DC. If you're going to give from the grid voltage, I'm going to give an AC to DC directly to the protected devices without introducing a DC to DC converter. There won't be reliable voltage to the circuits. To be honest, if I'm going to work under electronics voltage, then I should concentrate more even per unit voltage. Even point not one will diffuse the circuit. So in order to get the reliable a fixed DC input voltage, I am introducing a rectifier circuits. Probably a diode bridge rectifier will be there. So DBR will act as a converter which converts AC into DC, rectifies AC into DC. Then the fixed DC input voltage is provided to DC converter. Then the battery will get charged. There also we are going to use some protected devices like sensors to measure the voltage, current and the temperature, and the signals will be transferred to the BMS system. These input data are retrieved by the BMS. Your BMS will denote that what is the temperature of each cells, what is the current during a charging and the discharging mode, what is the voltage during charging and the discharging rating. Then the communication will be sent to the controller. From the controller, it has been transferred to through communication port, either CC or CP. That is a proximity pilot. This is the same system with a little bit modification for off-board charger. For both on-board charger, off-board charger, for this here it is an off-board charger. Definitely, I should prefer for a DC charging stations. That is, the charging station is required. The same other parameters. We need here also. We need to introduce a safety interlocks between the battery pack and the grid in order to ensure that the safety of the battery pack. Even though I am introducing a BMS here, the communication between the BMS and the controller should be communicated between PP and the CP, control pilot and the proximity pilot, so that I can knowingly at what percentage my battery pack is going to charge. That is the main function of the BMS here. So these are the various types of connectors and the cables. The commonly we are using SAE J1772, it's a North American standard for charging cables for level 1 and level 2. The CADMO charger for DC to DC charging. That is level 3 charging. high voltage battery pack. So level 1 charging is nothing but 120 volt household outlet is sufficient to charge your vehicles. That vehicle can be driven for 2 to 5 miles per hour. So home charging is sufficient. For level 2 charging also home charging is sufficient. Whereas in case of level 3, for going beyond 50 kilowatts, then definitely your vehicle should charge in the charging stations. See here 100 to 300 miles in 30 minutes. So 150 kilowatt charge delivering 100 kilowatt hour price 300 to 450 miles range in 1 hour. This is the longest distance they covered for under EV. So this slide will represent under level 1, level 2 and the DC fast charging. See the amperes required to charge your vehicle. So the battery capacity in terms of kilowatt hour, here I am shown in the charging load, that is 1.4 to 1.9 kilowatts. Here the charging load is not for battery pack. Battery pack always will represent in kilowatt hour. So here 12 to 16 amps for level 1 charger. Level 2 charge is 12 to 18 amps. See, greater than 100 amps. So definitely we should not charge your level 3 charging vehicle. We should charge using a CADMO charger by using or in the charging station. Because if you're going to use a home charging here, the 100 amps, then the heat exhibited through cable via charger and the battery pack will cause negative sequence. So most two-wheeler segments is an 120 volt AC household socket will be getting a 230 voltage. So for level 1 charger also better we prefer charging stations. Even though we can able to reduce the voltage from 230 to 120 voltage, a separate charger will be provided for level 1 charger also. But it can able to drive only 8 kilometers. Whereas in case of level 2 charger, see here, level 2 charger, it rated from 240 voltages where we are getting in our homes. So I can able to plug directly from the 16 amp socket. Then I can able to charge my vehicle. It can able to drive for 25 to 30 miles per hour. Level 3 chargers, it is powered directly a DC to DC charger instead of retrieving a voltage from the grid system. That is, instead of AC, here we are using a DC to DC charging because here a 400 voltage is required. I can able to have a long extended range vehicles up to 200 miles, exactly 320 kilometers within 30 minutes. I can able to travel with the capacity. That means which comes under the level 3 charge. So this is a schematic representation of the level 3 charges. So this is the key insights. So without the charging stations, you can't be able to charge your vehicles. The high power fast charging circuit is required. It is very difficult to charge my vehicle in my home. It comes under the level 3 charges. So in this slide, I have shown which when the charging comes under the level 1 charger, the requirement is 120 voltages, the maximum the capacity of the battery pack, right? 1.3 to 2.5. See the charging time required 40 to 50 hours. So this is the one of the drawback in level 1 chargers. Even going to charge the vehicle for 50 hours, I can able to travel with lesser distance. That is only 5 miles. Because the battery capacity of the battery will be very low. Whereas this is level 2 charger, the maximum charging hours requires maximum 6 hours based upon the converters. But I can able to drive my vehicle 45 miles per hour. See the requirement of the motor 50 to 350 kilowatts. This is our ultimate target as of now. Here the charging time requires 20 minutes to 1 hour. Now the Tesla is doing under research, not doing under research. Why not? It can be reduced less than 15 minutes for single charging. Right? Here for DC to DC charging, we will be using an CADMO or a Tesla charger, or you can say that high fast charging circuits. For level 1, level 2, SAE J1772 is the international standard charger, North American standard. We will be using in India also. Right? With this, I'll end my session. Thank you. Thank you for your patience. If any queries, you can raise your questions. Thank you.